Hello, this is Mrs. Thompson, and today we will be talking about the graphs of the tangent, cosecant, secant, and cotangent functions. The graph of the tangent function has a period of pi. So this function is repeated each time you travel a distance of pi along the x-axis. The definition for the tangent function is or equals the sine function divided by the cosine function. Of course, we cannot divide by 0. Therefore, anytime the cosine of the angle equals 0, your tangent function will have an asymptote. The tangent function, on its most popular, its fundamental period, has 3 popular points that you should learn. 0, 0, which is of course in the middle of the graph of the tangent function. Negative pi by 4, negative 1. Of course, we see that point here. It is labeled. And also pi by 4 as an x value, while y equals 1. That point is also labeled here. Using those 3 points and the asymptotes, we are able to make a nice sketch of the graph of the tangent function. You can think of this graph as being half of 2 parabolas with a vertex at 0, 0. To your right, you have the half of the parabola that opens upward, and to your left, you have half of another parabola opening downward. I've just shared with you the most important information about the graph of the tangent function. However, more information about the tangent function, along with what I just shared, is available on this slide and the next slide. Moving on to the graph of the cotangent function. The definition or formula for the cotangent function is or equals 1 divided by the tangent function. Again, we cannot divide by 0, so whenever the tangent function equals 0, you will have an asymptote that will create an asymptote on the cotangent function, on the graph of the cotangent function. Like the tangent function, the period of the cotangent function is also pi. And the fundamental cycle is color-coded in blue on this slide. The cotangent function has 3 points that you should learn for graphing. That is an x value of pi by 4 paired with a y value of 1, an x value of pi by 2 paired with a y value of 0. This point, as you can see on the graph, is acting as the vertex of the 2 parabolas that halves come together to form the graph of the cotangent function. And that third point being 3 pi over 4 as an x value paired with or while y equals -1. So like the tangent function, we see our vertex at pi by 2, 0. Of course, this time our graph is the half of the parabola opening upward but to your left, joined with the half of another parabola opening downward to your right. Of course, graphs for the cotangent and tangent function approaches our asymptotes, but they do not cross the asymptotes. Moving on to our last two reciprocal graphs. Our secant function is the reciprocal of our cosine function. Therefore, the secant function is defined as 1 divided by the cosine function, the cosine of x. Since the denominator of the secant function is the cosine function, this means anytime the cosine function equals 0, you will have an asymptote on the graph of the secant function. Because of the reciprocal relationship between secant x and cosine x, we first draw the graph of y equals cosine x for reference when graphing y equals secant x. Of course, in a previous lesson, you have already learned how to graph the cosine function. It is graphed here again for reference. Notice, once the cosine function is graphed for reference, you have it gives the maximum and minimum values for the secant function. We can see that the secant function consists of two parabolas. When the cosine function is going up, when it has a maximum, the secant function is a parabola opening upward, approaching both asymptotes, but never crossing them, with a vertex at that maximum value on the cosine function. Likewise, when the cosine function has a minimum value, the secant function opens downward. As you can see, it approaches the asymptotes while opening downward. You can also see that minimum value on the cosine function serves as the vertex of the parabola on the secant function. Additional information about the secant function is provided here on this slide. However, the most common features have been highlighted at this point. I would also like to point out that the period of the secant function is the same as the cosine function that it is a reciprocal of, that period being 2 pi. Lastly, taking a look at the graph of y equal cosecant, the cosecant of x. The cosecant function is the reciprocal of the sine function. Therefore, to graph the cosecant function, we first graph the sine function and any asymptotes. The sine function has already been covered in this course, but you see a sketch of it here. So graphing the sine function because it serves as a reference to assist us when graphing the cosecant function. Again, we cannot divide by 0, so anytime the sine of x is equal to 0, that will create an asymptote on the cosecant graph. Just like the graph of the secant that we just covered on the previous slide, you can see likewise that when the graph of the sine function has a maximum, the cosecant function is a parabola opening upward, approaching the asymptotes but not crossing, and that maximum value on the sine function serves as the vertex of a portion of the cosecant function graph. Likewise, you can see that when the sine function has a minimum value, the cosecant function opens downward with a vertex at the minimum value on the sine function. So, like the secant function, the cosecant function consists of two parabolas. Its period is also the same as the period of the function it is the reciprocal of, which is 2 pi. The most common graph section of this graph is the fundamental cycle, and that is indicated as always in blue. You will be performing translations of the graphs shared in this video and PowerPoint. Therefore, take the time to learn the information that was pointed out in this video. By learning this information, being able to perform translations with these graphs, like you have performed before with the sine and cosine graphs, will be much easier